Hi everyone, welcome to another tutorial of MATLAB Simulink. I'm Amir Hossein, and in this video I'm going to simulate a single phase inverter. To begin with, I open my Simulink, I add MOSFET blocks, I try to disable the measurement points, so I need 4 of them. Let's connect them. I also need a DC voltage source. So let's add that too. Be careful about your library that you choose. I set its value to 500 volts. And in this video, I want to add several loads, which at the first I try a resistive load, after that a capacitive load, and finally an inductive load. And the key point is that I want to keep the uh, our load current to a constant value of 100 milliamperes. So I calculated the values for my load and I just put them here. For our first simulation, our load is resistive. So let's add the power GUI and pulse generator. Let's call this MOSFET number 1 and this one number 2. No, it cannot. This is 1, 2, 3. Let's change their name. MOSFET 1 and this is MOSFET 2, MOSFET 3 and MOSFET 4. As you know, the principle of inverting a DC wave to an AC wave is that by flowing our current in a cycle from this MOSFET to this and exit from this MOSFET, and at the other half of our cycle flow it from this MOSFET to this MOSFET. And the reason of using freewheel diodes is because we have both inductance and capacitance in our load, and so we should activate our these two pair of MOSFETs when the other two are deactivated, and activate these two others while the other two MOSFETs are deactivated. So we need a NOT gate. All right. And now let's add our measurement blocks. And before that, let's set this. So our period is 0.02 seconds and our pulse width should be 50%. So half of the cycle. These two are activated and the other two are deactivated, and the other half of our cycle, the other pairs are activated and the others are not activated. So that's all right. We should also measure our current measurement. So, and this connect to this part, and we need a scope. Also, I want to display the my name of my no, let's say RMS of my current display. Now let's decrease the time to 1 second and run. So let's observe our plots. We have 4. So let's check it out. As you can see here, the first plot is the voltage of our activated for these two pair of MOSFETs, and the other plot is the voltage of these two other MOSFETs, and it is exactly opposite the of each one. And the third one is our voltage, and the fourth one is the third one is our current, and fourth one is our voltage, which as we can see it, the value of each one depends on the on our resistance value, but their shape is exactly the same. And let's check our current, uh, which it is actually I changed it. It's the wrong value because it's calculating the value of voltage. We should connect it to our current, which it equals to, let's run it again. Yes, it equals to 100.9. So now let's change our load to a inductive load. So I change this to 16 milliohms, 16 millihenry, and 0. That's alright. Our current value is approximately near to what I expected. So now let's discuss our waves. So as we could expect, the shape of each pair is opposite to the other one, but the most important thing we want to discuss is in this area, which, as you can see, from this part until this part, each of diode 1 and diode 2 is activated until this place. And this is because of our inductance effect. And this plot shows that the switch 1 and switch 2 are activated as well. And from this part of our plot, the peak, until the half wave to the lowest part of our plot, here this area is about activation of diode 3 and diode 4, and this area is related to activation of switch 3. Actually here they are deactivated, the activation of switch 3 and switch 4. And as we can observe, the shape of the plot of current and voltage have a lagging shape because the current is before our voltage. I hope you understood what I mentioned. And let's change our load to a capacitive load. I set this to 1.3. Here 25e minus 6, and here minus 3. Okay, let's run it. Yes, our current is approximately to 100 milliamperes, and let's see the results. As we can see here, our voltage wave is behind our current waves because our load is a lead load. I hope you enjoyed this video, and don't forget to subscribe to my channel so you won't miss the upcoming tutorials and videos. Have a good time and goodbye.